recording, so it'd be helpful if you, if everyone, including Talmadge is always the one that's talking. It'd be helpful if everyone else would talk. Sometimes Greg does. We're going to talk about conditional statements. You hear them all the time. You've already heard me say one. If you don't do the flipped classroom on Thursday, then what happens on Friday? Then you don't play the game, okay? If you don't do your homework, then what happens? Then you get a 0, or then your mom gets mad. We could do a happy one. What's a happy one? If you get a good grade, then your mom's happy. Then you get ice cream, things like that. So conditional statements, we're going to talk about them. This is at the top of your page. You're not going to write this down yet. I'll tell you when to write it down. In this lesson, you'll study type of logical statement that's called a conditional statement. This is the part you will write down. A conditional statement has 2 parts, a hypothesis and a conclusion. So we're putting this away for now. You're doing this at the end. It has 2 parts, a hypothesis and a conclusion. You've heard the word hypothesis before, yes? Okay, you've heard it in, hopefully, like biology. Not biology. Yeah, biology. Okay, it's any science. Hypothesis and a conclusion. So, whenever you see a conditional sentence, it will say if and then. Those are like the highlight words. So you see this on your notes. It says if P, then Q. You're going to take one color of your highlighter. I'd highlight the letter P. Remember in math, letters often represent something. If you're looking at the color coding here, what do you think P represents? Look at the color coding on the page. It represents the hypothesis. So I'd highlight it and write that P represents the hypothesis. And then what does Q represent? The conclusion. So all of your conditional sentences will look like this. Is if a part of the hypothesis? Look at the color coding. Is if a part of the hypothesis? No. Okay. If and then will not move. If and then are like the structure of the sentence. If will always be the first word of a conditional sentence. Okay, so I think I show you an example here. If you are in this class, then you are taking geometry. What is the hypothesis? You are in this class. So notice if is not a part of the hypothesis. All right, and then the conclusion is you are taking geometry. Okay, so you're going to learn geometric properties that go with this and why it matters later on. But what you're going to do is part of your test will have symbols on it. Basically, if you learn the symbols, it's easier for you later on, and I'll explain it when you see all of them. Okay? So if you wanted to write if P then Q in symbols, you would see P arrow Q. Okay? I would write that down. So anytime it asks you to write a conditional statement, it'll say P arrow Q. This means P implies Q. And again, P represents the hypothesis and Q represents the conclusion. All right, so we're going to use the hypothesis and the conclusion. This is in the center of the page next to the hole punch. Mine says different directions. What does yours say?
Underline the hypothesis and circle the conclusion.
So mine says, yours says underline the hypothesis, circle the conclusion, and then we're going to rewrite it in if and then form. Okay, so can anybody take a guess at what the hypothesis would be? Our sentence is all members of the soccer team have practiced today. So if what? If you're a member of the soccer team. So if you're a member of the soccer team, what's the next word that should be there? Then, and then your conclusion would be? You have practice today. Is it today? Yeah. So if you're a member of the soccer team, then you have practice today. So basically you're going to split these up between the subject and the verb whenever you see these. What is the subject of a sentence? In layman's terms? What it's about. So this is about the members of the soccer team. And then the verb of the sentence would be have practice. Okay, we'll just have actually. So you want to split it there. So what we're going to underline is the hypothesis. So we got the hypothesis from the members of the soccer team. So you underline the hypothesis. And then what do we do with the conclusion? Circle it. This is what your homework will look like whenever you get there. It'll say underline and then circle. All right, we're going to go back to the terms. You're going to learn a new term. It's not really new to you. A statement can be altered by negation. What does negation sound like? Negative? Yes. Negate is the shortened version of negation. So basically, whenever you do a negation of a sentence, you're going to write the opposite of the original statement. So you're going to write the opposite of the original statement. This is a term. So write the opposite of the original statement. We'll see if you catch on. If we had a statement, the measure of angle A is 30 degrees, the negation would be the measure of angle A is not equal to 30 degrees. If we had a statement, angle A is not acute, what do you think the negation would be? Angle A is acute. Okay, so these should be really simple. Let's see. I am not running. The negation is I am running. We'll do our examples. Go ahead and write down the symbol. It's a squiggle. It's a squiggle. I know that there's a proper term, and I'm sure Miss Brown would hate me for this, but I call it a squiggle. It is what it is. So to write the negation of a statement P, again, what does P stand for? The hypothesis. You write the symbol for negation before the letter. So if you wanted to say not P, you would write a squiggle P. So here's what that means. Give me a hypothesis if something. If the board is clear. Okay. So basically what would happen is you would negate it. You would say if, and then what's the negation of the board is clear? The board is not clear. So you don't change the words. You just add the word not or you take away the word not. Like in our examples, this is in the lower half of the page. You should see the car is white and then it is not raining, or sorry, it is not snowing. So you can't change the words of the sentence. In order to do the exact opposite, you use the word not or you take the word away the word not. So the car is white, the opposite would be the car is not white. So the answer is not the car is black. Okay, because that's not the exact opposite. So you just add the word not. It is not snowing, it is snowing. Okay, so that's negation. So the reason I emphasize that is on your test, you might have a multiple choice question, and it would say which of these is a negation. And it would say the car is not white, the car is black, the car is gray, the car is not white, or something stupid. Okay, so make sure you choose the one that just has not added in. Okay. All right, so this is where we learn about different types of conditional statements. The first one is called a converse. When you think of the word converse, what do you think of? Shoe. The shoe. So nowadays you have very much different popular shoes. What shoes are popular now? Nike, Adidas, Vans. What else? Jordans. Okay. I don't even think Jordan had a shoe out when I was in high school. That's something I'd like to look up. Anyways, so what was popular when I was in high school was a Converse. Okay. P.S. Crocs are really popular right now. We used to make fun of them a lot and make fun of the people that wore them. We also used to make fun of scrunchies. made fun of a lot of things that came back in style. So it's very interesting to see that. But anyways, Converse are pretty classic. I don't think anybody makes fun of Converse. Now you have white Converse. We just always wore the black Converse. But in order for me, so think of middle school. Try not to think of middle school me, but middle school me, I had Converse like everyone else. And in order to strike my originality, okay, to make my statement, I had like a billion different types of shoelaces. So what I would do is every day, literally every day, because what else does a middle schooler have to do? We did not have cell phones. We did not have social media. If we did, it was MySpace, and you could do it on your computer. I didn't have internet. We had this device that you, it's illegal. You stole internet from someone else. So basically someone else had to be, you didn't steal it. You just,
Borrowed.
yeah, if you like using someone's open Wi-Fi. But it was not called that. It was like this thing you plugged in. Anyways, so basically you had to wait for a neighbor to get online, even to use the computer, unless we played pinball, okay? That's pretty much it. So anyways, me having nothing else to do with my life, I changed my shoelaces every single day, like to whatever the occasion called for. If the Gators were playing, I wore orange and blue. If it was Christmas, I'd wear, green and red, so on and so forth. It was just my thing, okay? So there's a reason I'm telling you this. What's going to happen with a Converse statement? I always switched my laces, okay? So if nothing else on the way to school, if I forgot to do it, I would just switch them. So if I had orange and blue, I would switch to blue and orange. You get the point. So a Converse statement, you're going to switch. So don't write the word exchange. You're going to write switch. You're going to switch the hypothesis and the conclusion. It's a term at the top. So you're going to switch the hypothesis and the conclusion. I actually still own the same pair of Converse because women stopped growing. I've been this tall most of my life. So, here's what you're going to know. The symbol, so what would come first if you're switching the hypothesis and the conclusion? The conclusion, so it'll say if, come on. It'll say if Q, because Q represents the conclusion, then P. So what do you think this would look like in symbols? Yep, you were saying it. Q, arrow, P. Okay, because this represents the the conclusion first and the hypothesis second. Okay, so conclusion first, hypothesis second. The next one's called an inverse. I don't have a special story for this other than when you hear the word inverse, what letter do you hear? N. Okay? So you hear the word N. What you're going to do is you're going to go back to the conditional where the hypothesis comes first and the conclusion comes second. But you're going to negate the hypothesis and the conclusion. So you're going to negate the hypothesis and the conclusion. Oops, sorry. So we'll give an example. That's not English. So give me a really simple hypothesis, if something. Blake, this is all you. Give me a simple hypothesis. Simple meaning not a lengthy one.
Math is hard.
If math is hard, this isn't even math, but okay. If math is hard, then
I don't know.
we'll figure something else out. Oh, wait.
You should study more.
Okay. That's fine. We'll say study, just so I don't have to write more. Okay. So, the converse. Here's what you're going to do. What is my hypothesis? Math is hard, and the conclusion is you should study. So the converse means you're going to keep if and then in the same spot. What you're going to switch is the hypothesis and the conclusion. So what I have underlined. So what would come first? If. Okay, so instead of saying you should study, you would say if you study. This one won't make sense. But if you study, then math is hard. Okay. The inverse, so I'm not saying all of them make sense. Okay. The inverse you go back to the conditional. So the hypothesis is first, the conclusion is second. But what are we going to do to each of these statements? Negate them. We're going to negate them. So if math is not hard, then you should not study. Okay, this is not true, but you see. So in words, if not P, then not Q. So the symbol, P is going to come first, Q is going to come second. But what is the symbol for negating both the hypothesis and the conclusion? What did the symbol look like to negate? It looks like a squiggle. So you're going to squiggle P, squiggle Q. Come on, there you go. Squiggle P, squiggle Q. Sets the symbol. The last one is a contrapositive. Here's how I remember it. It is the longest word. Yes, we agree? That is much longer than any of the other words. It is the one you do the most work for. That's the way I remember it. Because what you're going to do is you're going to switch and negate. So you're going to switch and negate the hypothesis and the conclusion. So switch and negate. The hypothesis and the conclusion. All right, so then which one comes first, hypothesis or conclusion? Conclusion, which would mean Q. But I'm going to negate it. So squiggle Q, and then what happens next? What do you think? Squiggle P. Okay, because you're going to do the negation of the conclusion and then the negation of the hypothesis. We're going to do the sentence at the bottom of the page. This one will make sense. Promise. Ready? So, you see this at the very bottom. Let P be you are in New York City, and Q be you are in the U.S. Write each statement in words and decide whether it is true or false. So what part of this is my hypothesis? Yes, which is you are in New York City. And then which part of this is the conclusion? You are in the U.S. So, we're going to go through each of these. When it says P arrow Q, which type of conditional statement is this? Don't overthink it. It's a conditional. So I'm going to write conditional if you did not write them anywhere else. What does every conditional statement start with? If. So I'm going to write if for all of them because they will all start with if. Every single one of them. All right, so then what will come first in my conditional? If you're in New York City, what's the very next word going to be? Then, and then we're going to say you're in the U.S. And then we have to decide if this is true or false. So if you're in New York City, are you in the United States? Yes, you are. That is true. All right, the second, we have Q, then P. So what kind of conditional statement is this? It's a converse. So just like my shoe laces, I switched them. You're going to switch the hypothesis and the conclusion. So what will come first? If you're in the U.S., then you're in New York City. Do we agree? I do not agree. We're definitely in the United States, and we're definitely not in New York City. So it is false. Good. All right, the next we negate P and negate Q, so this is, yes, which is called the inverse. So, what is the negation of you are in in New York City? Sorry. You're not in New York City. Good. Then you're not in the U.S. So true or false? False, because we are definitely not in New York City, but we are still in the United States. Oops, sorry. All right, and then the last one. You negate the conclusion and then negate the hypothesis. So this is called the contrapositive. So if you pause, I can try to make your life a little easier when you end up doing these. Contrapositive. All right, so everyone look. In the converse, what did we do with the hypothesis and the conclusion? We switched them. In the inverse, we negated them. So the contrapositive, we want to switch and negate. So to make it easier to keep track of what you can do, you can look at the converse. The converse is already switched. So what is the only thing that you would need to do to make it a contrapositive? Negate it. Or you can look at the inverse. It's already negated. What would you need to do to make it contrapositive? You'd need to switch it. So you can look at either one of these two and use it as like your base. So what will the first part of my statement look like? If you're not in the U.S., so if you're not in the U.S., then you're not in New York City. Do we agree or disagree? We agree. It's true. There's only one New York City in the entire world, and it's New York, New York. Good. Go ahead and flip. We're almost finished. We're finished with the sentences at least. The last bit, this is the part of geometry we're going to talk about. Go ahead and highlight the word perpendicular. I believe that's the word, right? Perpendicular lines is up there. Okay, go ahead and highlight perpendicular lines. You can write a definition as a conditional statement. And you can also write the converse. So here's what happens. This is why we just learned what we learned. The rest of geometry, definitions will be written like conditional statements. So will properties. So sometimes the property will be correct the converse way, and sometimes it won't be correct. You'll just see it. So, perpendicular lines, this is a very important word in geometry. If you don't know what it is, the rest of geometry, you will not do very well. Okay, because you're going to see it, and it's going to be understood that you know what it means. So, what I would write, perpendicular lines are two lines that intersect and form a right angle. So, two lines that intersect and form a right angle. Two lines that intersect and form a right angle. So, two lines that intersect and form a right angle. So the definition in your textbook, it says if two lines intersect to form a right angle, then they are perpendicular lines. So you'll see a picture that looks like this. How do I know these two intersect and form a right angle? What this picture tells me. That box, okay? So there's a symbol for this. The symbol, oops, sorry, I'll let it pop up. This symbol is this upside down T. That's what you should write in the symbol section. So an upside down T. So they said line N is perpendicular to line M. Why do I not like the way they named line N and line M? What are they missing? Line. Yeah, the word line. Okay. So these two are perpendicular because of that little box. Okay. Anything in life that is a vertical line, meaning a horizontal line, is perpendicular. So we're going to name some in my room. So what's perpendicular in my room?
The ceiling.
The ceiling. What part of the ceiling?
The screws.
Yep. Where all of them intersect, those are perpendicular. Where else? Yep. Every single intersection, we have a horizontal line and a vertical line. So these are all right angles. So these lines are perpendicular. Where else? Where? The calendar. Yep, correct. On my board, horizontal line. Sorry, that's a vertical line. Horizontal line meeting. That's a right angle. Every corner of a door is a right angle. Corner of cabinets is a right angle. What a doofus. Is this open? Thanks, CJ. Or whatever his name is. No, what's his name? Not CJ.
TJ?
No, the other one. Xander. keep trying to call him Xavier. Anyways, so here's why it's important. So I want everyone to envision this. Okay, I guess I have to draw on my iPad. Let's envision that this horizontal space is the ground. Okay, so every time a building is built, the building has to be perpendicular with the ground. Can anybody guess why it has to be perpendicular with the ground? So it doesn't fall over. That would be what I would say. So basically, if it was anything less or more, so let's say it was barely less than 90 degrees. Okay, what happens as the building gets taller? It leans more and more and more, right? Okay, it would not be stable. What building in life? Yeah, Leaning Tower of Pisa. If you looked at it, the angle it makes with the ground is not 90. That's why it leans. Okay, so you see it there. You see it in windows. You see it in a lot of things. The door would not close properly if it didn't have right angles in the corners. Okay, so that's why it's so important. So here's what you're going to do. These are all things we're going to talk about. You're going to look at a diagram and decide whether things are true. Okay, so the measure of AEB is 90 degrees. Do we agree with this? Yes, we do, and it says explain. So why do we agree with it? It has the box. So you're going to say true. You're going to call it the right angle symbol. That's the technical way to call it. So true, because it has the right angle symbol. And that symbol means 90 degrees. You don't have to write that part, but we all know it. So true, it has the right angle symbol. Points A, C, and D are collinear. What does collinear mean? On the same line. So is this true? No, it's false. Why is it false? Because D is not on the same line. So you'd say false because D is not on the same line. Letter C. We have AC, array AC, I mean. And then we have ray CA, our opposite rays. Opposite rays have three things, okay? All the points are on the same line, so they're collinear. Is that true? Yes. They have the same endpoint. Is that true? They do not have the same endpoint, so that's what's false. So you're going to say false because they don't have the same endpoint. So false, they don't have the same endpoint. What was the last thing that made opposite rays opposite rays? It's not the hard one. They point in opposite directions. Good. So then CA points left, AC points right. Okay, so false because they don't have the same endpoint. You're going to go ahead and take out your textbook.